In the last unit we said valence electrons are important because they're involved in bonding. So in this lesson we're going to take a look at what I mean by bonding and how bonds form and the different two major groups of bonds. Those bonds are ionic bonds and covalent bonds. So first, what is a bond and how do we figure out what's going on? Well, let's get back to our electrons. Remember the group number, that's the column on the periodic table, tells us how many valence electrons an element has. So as we move from left to right, that increases by 1. So if we go across the second row or the second period, lithium is in column 1, so it has 1 valence electron, beryllium has 2, boron 3, carbon 4, nitrogen 5, oxygen 6, fluorine 7, and neon 8. Remember the octet rule says that 8 is our magic number. If we get to 8, then it's stable and it won't form bonds, which means 1 through 7 are unstable and will form bonds. They either want to give up electrons or gain electrons to get to 8. And that's what happens when a bond forms. Electrons are going to be shared or transferred from one atom to another or between atoms in order to become stable. So group 1 is the most unstable metals. They really want to get rid of an electron. And we're going to have a tool that helps us figure out what's going on. These are called electron dot diagrams or valence dot diagrams. And so if you think of a metal like sodium, sodium has the symbol Na. We could draw out all its layers. And so the first layer for sodium has 2 electrons in it. Okay, and it's full. And then we go to the next layer, and that next layer would actually have 8 electrons in it. Okay, 2, 4, 6, 8. And then the next layer has 1 electron in it. Well, only the valence electrons are involved in bonding, so I don't really want to draw all that. I don't want to have to keep track of all that. I only care really about that 1 electron on the outside. So instead of drawing all of those, I can get away with just drawing the symbol Na, which represents all the protons and neutrons and all the inner electrons, and then I'm just going to draw its valence electron, and it has 1. So I put 1 dot on it. I can have up to 8 dots around this because I can have up to 8 valence electrons. No side will get more than 1 dot until every side has 1 dot. So no side gets 2 until every side gets 1, with the exception of helium. Helium gets 2 because paired electrons don't bond, and helium doesn't form bonds because 2 electrons fill that first layer. So group 1, they're the most unstable metals. They're called the alkali metals. They have this 1 valence electron, and if they could get rid of it, they'll be stable. And I'll show you a picture about why in just a second. Okay. Group 7 is the most unstable metals. They really want to gain an electron because they have 7. Fluorine would be F, and it has 1, 2, 3, 4, 5, 6, 7 valence electrons, and so it's got this big open spot here. If it could fill that in, it would have 8 and it would be stable. So the most unstable nonmetals, those are called the halogens. They have 7 valence electrons. They're over in group 7. Remember, group 8 is the noble gases. Okay, and the noble gases, they do not form bonds. The noble gases do not form bonds. They already have their 8 valence electrons. They don't need to do anything. Okay? So we can get to these 8 valence electrons by either transferring through an ionic bond or sharing electrons through a covalent bond. And the result is that we have more stable atoms when we're done. If the elements that are bonding are different, then when they bond, they form a compound. If the elements that are bonding are the same, it's not called a compound. It's just a molecule generally. When identical elements bond, it's not a compound. So here's a periodic table. Over here we have the alkali metals. You'll notice I excluded hydrogen from that. Everything in this column has 1 valence electron, including hydrogen, but everything over here in this column is a metal. These are metals, 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 metals. This step line here, that separates the metals from the nonmetals. So over here we have nonmetals. Okay? And if you forget that, pick an element you know about. Oh, here's iron. Everything over here on the left side is a metal. Everything over on the right side, non-metal. The zigzag line is the metalloids, or the semi-metallics. And metals, because they have 1, 2, 3, or 4 valence electrons, it's faster for them or easier for them to give away electrons and form positive ions. Nonmetals tend to take electrons and form negative ions. So let's take a look at some ions and ionic bonds. An ion is a charged atom, and it became charged by gaining or losing electrons. If you gain an electron, that means you have more electrons than protons, which means you have a net negative charge. So it's a negative ion because it gained a negative, and a negative ion is called an anion. The nonmetals gain electrons. If you lose an electron, you'll have more protons than electrons. That means you'll be positive. A positive ion is called a cation. The metals lose electrons. Okay. An ionic bond forms when an electron is transferred from one atom to another, and then those oppositely charged ions attract and stick together. So these form between a metal cation, because we need a positive, and a non-metal anion, because we need a negative. And they will form up in such a ratio that the two charges cancel each other, and the overall compound is neutral. That does not mean that they're always in a 1-to-1 ratio, though. Sodium has one valence electron, and it'll give it away and be a 1 plus. 1 plus. Chlorine has 7 valence electrons, 1, 2, 3, 4, 5, 6, 7, which means it takes one and becomes a 1 minus ion, and a 1 plus and a 1 minus cancel and those stick together. But magnesium has 2 valence electrons, so it'll give both of those away and become a 2 plus ion. Fluorine, on the other hand, has 7 valence electrons. It's only got room for 1, so it takes in that 1 electron and becomes a 1 minus. A 1 minus doesn't balance a 2 plus, so we need 2 fluorines, which is why MgF2 is the formula for magnesium fluoride. There are 2 fluorine ions for every magnesium ion, because a magnesium ion is a 2 plus, and there's only a 1 minus charge on that fluorine ion. So let's take a look at that with all of the electrons drawn out. Okay, so here's sodium. It's got 11 protons. This is sodium 23, so it has 12 neutrons. The first layer holds 2, second layer holds 8, and then it's got 1 electron out here in this last energy level. That's not stable because it's not 8. This one is stable because it is 8. So if this could get rid of that electron, it would drop down and look like that, which is why sodium gets rid of that electron. But now it's not an atom because it's not neutral. It lost an electron. It's got 10 total electrons and 11 total protons, which means it's got a 1 plus charge, so it's a sodium cation. This extra electron has to go somewhere, and chlorine actually has an open spot. It's got 2 electrons on the first level, it's got 8 on the next level, and then the last level is not stable because it only has 7. So if it pulls in that 8th electron, that makes it stable with 8. That fills our octet, and so now we have a chlorine with a 1 minus charge. That sodium is now stable, that chlorine is now stable, and they're going to stick to each other because they have opposite charges. That's an ionic bond. Covalent bonds work a little bit differently. Co is sharing together, working together. So covalent refers to the sharing of valence electrons. So if we look at a covalent bond, nothing's going to gain or lose an electron. Instead, we're going to share electrons. But when you share, you actually gain. Metals don't want to gain, so covalent bonds are only going to form between nonmetals. So nonmetals can take electrons or share electrons. Water is a molecule. Glucose is a molecule. Hydrogen and oxygen are both molecules. So a molecule is a covalently bonded substance. Ionic compounds are called ionic compounds, and they have ionic bonds. Substances that are held together with covalent bonds are called molecules. Now, there are 7 diatomic molecules, di as in 2, atomic as in atoms. So 7 diatomic molecules that are not compounds. They contain 2 atoms bonded together, but they're the same atoms, so they're not actually compounds. That's bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. These are the halogens. Okay, you'll notice bromine, iodine, chlorine, and fluorine are all group 7 nonmetals. They're very reactive, which means they really like to form bonds. So if there's 1 fluorine atom around, chances are there's 2, and they'll form bonds to stick to each other. Hydrogen, oxygen, and nitrogen are also fairly reactive. Nitrogen is actually a main ingredient in lots of explosives. So oxygen we need for fire. Hydrogen is also very, very flammable. So all of these are very reactive things, and so they're going to stick to other atoms that are like them because they want to form bonds. Now, in a covalent bond, we don't actually have electrons that transfer from one element to another. Instead, these things see each other and they go, hydrogen's got room for 2 electrons. Oxygen has room for 2 electrons, open spot, because it's only got 6 out here. So if that hydrogen and that oxygen could stick together, and these 2 energy levels could overlap, and those 2 electrons could hang out with both, then everybody's happy. Oxygen thinks it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons on that outer energy level. Hydrogen thinks it's got its 2. Remember, that first energy level only holds 2. So both of those are stable because they have their full octet. Hydrogen, of course, only goes to 2, but that's how a covalent bond works. We're sharing to get up to 8 instead of transferring to get up to 8.